fractions. Okay. Okay. Well, if you don't love fractions, today is your day because today is all about getting rid of fractions. So we still have to know a couple of things about fractions to be able to get rid of them. The first thing is how to multiply by fractions. Multiplying with fractions is really easy. It's adding fractions that's a little bit harder. I don't know if you remember this from years gone by, but if I wanted to multiply like 2/5 times 1/3, do you guys remember how to stay in your lane and multiply the numerators together?
Yes.
So 2 times 1 is 2, and then multiply the denominators together. 5 times 3 is 15. Okay, and then if it's reducible, we have to reduce it, right?
Yeah.
But is 2/5 reducible? No. They don't. 2 and 15 don't have any common factors other than 1, so we just leave it. Okay, so we just have to multiply straight across. So if we're going to clear fractions, which we are today, fractions. Okay, we're going to multiply both sides of our equation by the biggest denominator. There are other ways to do this, but this is probably the most straightforward. Okay, why would we want to multiply by the biggest? Well, okay, let's say that 10 was our biggest denominator. Or let's pick one I didn't use. Let's say 8 was our biggest denominator. Okay? Say I have a 3 over an 8. Now, if I multiply this and like some other stuff by an 8, do you see that the 8s are going to cancel?
Yeah.
Right? So that's why I have to pick the biggest denominator to multiply by, because the number that I pick to multiply by has to cancel my biggest denominator. Cool?
Yeah.
If I don't pick a big enough number, am I going to still have fractions? Yeah. Okay, so if your number isn't big enough, you're going to be stuck with fractions still. All right, so after we do that, we're going to simplify all the fractions, which is basically we're just going to divide. Okay. If we still have any fractions left, we just multiply by the biggest denominator again. And then we solve. Okay. So let's see how this works. Zoom in a little bit. Oh, a little bit more. Sorry, I'll get my act together over here. All right, so what do I multiply by on both sides?
The biggest denominator.
Yeah, which is?
6.
6. So we're looking at this 6, not that one. So we're going to multiply this whole side by a 6. Look at how high up my 6 is. Put your 6 nice and high. What is hiding under the 6? That we can't see, but we know is there. A 1. There's a 1 under there. Okay, and then we have to multiply this side also by 6. So the reason that we talked about multiplying fractions at the beginning is because it's going to help us distribute. Remember when we multiply numerators with numerators, denominators with denominators? So I'm going to distribute a 6 right up here. But what am I going to distribute on the bottom?
A 1.
1. Okay. It's really important. One of the biggest mistakes I see that kids make is they write like the 6 out here and they have the 3 halves. Don't write this. I'm just showing you. Minus 5 times 6. And then they try to do this. Do you see that that's actually multiplying by 6 over 6? Okay. And that's just a 1. So they think they're multiplying by 6, but they're actually multiplying by 1. So they're doing 1 on this side and 6 on the other. Is that okay if I'm trying to do the multiplication property of equality? You see why that's really illegal? Okay, so we're not going to do this. We're going to do this. All right, so 6 times 3. 18. 1 times 2, 2. Okay, I'm going to bring down the A, bring down the minus. Okay, I keep multiplying. 6 times 5 is 30. 1 times 6, 6. All right, what's 6 times 6? Yes. Okay, now for a second it looks worse, but it's about to get better because we're going to simplify. So what's 18 divided by 2? 9. Bring down the A, bring down the minus. 30 divided by 6? 5. Now, look at how friendly that looks. So friendly. All the fractions are gone. You're welcome.
Thank you.
Yeah. All right, so now I'm going to add 5 to both sides to get rid of the negative 5. That gives me 9a equals 41. And I'm going to divide both sides by 9. Does 9 go evenly into 41? Okay, this is our first snag. So I can show you how to use your calculator to check if a fraction is reducible, right? Because if we had 27 over 9, that would be just 3, right? Okay, if we had 21 over 9, there's a common factor of 3 in here, right? We'd be reducing it, but it wouldn't be a whole number. So I'm going to show you how to check what kind of situation we have. Okay, so on your calculator, do 41 divided by 9. Hit enter. You see it's a decimal. I really want it a reduced fraction. So if I hit math, and you see how 1 is frac? I can just hit enter and then enter again, and it will give me a reduced fraction back. And if I see that it didn't change, I know it's already reduced. Let me show you what I mean. Look at 3 divided by 15. We all know that 3 and 15 have a common factor of 3, right? But it's still a fraction. So if I hit math, enter, enter, it reduces 3/15 into 1/5 for me. Boom. Okay, so your calculator is programmed to always give you the reduced one back. So if it gives you the same thing that you started with, it's already reduced. Cool?
Cool.
All right. So our A, it's a little bit weird, but it's just 41 over 9 and we're done. We don't have to do anything else to it. I know in middle school, they like to do mixed numbers and all that stuff. From now on, algebra and up, improper fractions are your friends. I know it kind of makes you uncomfortable to look at, like you feel like you should do something with it, but it's actually correct and we just leave it. Okay, so we're just going to practice being uncomfortable and sit in it. Okay, here we go. Here's the next one. I'll leave that as an example so you can still see it. All right, what are we going to do? First,
Find the biggest denominator.
which is
10.
10. So I'm going to multiply this side by the 10. And this side by a 10. Remember to put the 10 up nice and high, because what's hiding under there?
A 1.
A 1. Okay, 10 times 2 is 20. 10 times 9, 90. 1 times 10 is 10. Okay, bring down the x, bring down the minus. My 20 is kind of floating. There. Okay, let's keep multiplying. 10 times 4, 40. 1 times 5,
5.
5. As long as you know which things get multiplied by what, this is very easy computations, okay? But you have to be neat, because as soon as you start like skipping steps and like not lining things up, it gets really confusing. Do you see how that could happen?
Yeah.
Okay. All right, let's reduce some fractions. 20, I just leave. 90 divided by 10, 9. Bring down the x, bring down the minus. 40 divided by 5, 8. What do you think? Add 8, okay. Convinced. You convinced me. So now I have 28 equals 9x. Divide by 9. Does this reduce? Okay, everybody test it.
It stays the same.
It stays the same. Okay, so we're probably going to get some weird numbers on this homework assignment with these clearing fractions. Fractions are numbers too. Okay. What do we do first? Which is? Okay, so what do we do with 12? Okay, both entire sides get multiplied by the 12. I'm going to tuck a little 1 under the 12 so I don't distribute incorrectly. Okay, so I'm doing 12 times 2, that's 24. 1 times 3 is 3. Bring down my b, bring down my plus. 12 times 7. Woo! I know what it is now, but I've already done this problem twice today. I get 84. And then 12 times 1 is 12. 3 times 12, 36. Okie dokie. 24 divided by 3, 8. Bring down the b, bring down the plus. 84 divided by 12, well, we just figured that out. It's 7. We just used 12 and 7 to get 84. And 36. Subtract the 7. $20 what? Yeah. So 8b is 29. Gotta divide. Does it reduce? Okay. Okay. So, have you ever seen a crazier bunch of gibberish in your life?
Yes.
Oh, okay. Well, let's look at what it tells us to do. It says solve for beta. What does that mean? If it said solve for x, what would we do? We would get x all by itself. So if it says solve for beta, what do we do? We just get it by itself alone, right? So we don't actually have to find a numerical value for beta. We can't. We've just got a bunch of like gobbledygook, right? Symbols. But we can rearrange this so that beta is all alone on its side of the equation. And that's what we have to do. Cool? What operation is happening between the 7, the pi, and the beta? It is multiplication. They are being multiplied. How do we undo multiplication? We divide, yeah. So we want to get rid of multiplying by 7, so we have to divide by 7. We want to get rid of multiplying by pi, so we divide by pi. And if we do it to the right, we have to do it to the left. Okay? My 7's cancel. My pi's cancel. And ta-da! Beta is all alone on its side. On the left side, I have a d in the numerator of a fraction, and I have a 7 and a pi in the denominator. And guys, that's it. That's all I had to do. We're done. I didn't have to find a value. All I had to do was rearrange it so that beta was all alone. Just one step. If they're multiplying on the right, they're going to be dividing on the left. Do you see that?
Yeah.
Cool. Okay. Let's look at example 8. I think you guys can do this one. Go ahead and give it a try. So, between the L and W, we have more multiplying. How do we undo multiplying?
Divide.
Yes. So we have to do it to both sides. That gives us our W alone and an A
Could you please
over
send
an
Casey
L.
Cutler to the office? She will be leaving.
Yes.
Thank you.
You're welcome. Okay. Questions? Okay. Okay, we're leveling up. Okay, this time we are solving for y. So, if I want my y's alone, is it okay for me to have those x's hanging out?
No.
No, we got to kick them out of the party. All right, they're getting bounced. So, they're positive. To kick them out, I got to subtract them from this side and from this side. Party's over, guys. Go home. Okay, so now I have my 7y equals, are 14 and 3x combinable, or should I just write them as separate terms? Separate terms, okay, they're not like terms. I just keep them separated by the subtraction sign. What property allows me to subtract 3x from both sides? Subtraction. Property of equality, that's it. All right, do I want the 7 with the y?
No.
What operation is happening between the 7 and the y? Multiplying. Okay, we have a lot of experience now in doing multiplying. What do we do? Okay, good recovery. So we're going to divide this side by 7, and also this side gets divided by 7. The whole side. So these cancel, and I get y equals 14 divided by 7 makes 2. Okay, Okay, bring down the negative. What about 3x over 7?
Maybe say it's 3. I mean,
Yeah, it just stays 3x over 7. So 3 over 7 with an x. You can either write the x next to the 3, or you can write it on the top with the 3. These two are the same. It does not matter which way you write it. Okay. What property allowed us to do that? Yes, it is the division property of equality. Now, I know it's kind of weird to get an answer that looks like this one that we just got, but do any of you remember from last year y equals mx plus b?
yes.
Okay, so if I do a little bit of a flipperoo here, do you see that I would have y equals negative 3 over 7 x plus 2,
Yeah.
where the b, the 2, is the y-intercept, and the negative 3/7 is the slope? Okay, so in a few units, we're going to be using equations like this to graph lines. We're going to put a y-intercept at 2, and then we're going to go down 3 from the rise, 1, 2, 3, and right 7. Find a new point. There's our line, pow. So the reason that this looks crazy is it's because it's the equation for a line with a crazy looking slope. Okay.